Next panelist is Andy Ellis. So Andy was an undergraduate at MIT, where he studied computer science, and then he was an officer in the Air Force specializing in information warfare. Now he's the Chief Security Officer at Akamai. Andy?
Thank you. So I guess I don't have to tell folks what Akamai does, since I think George did a great introduction on that one. Security is sort of an interesting thing for Akamai and for anybody who works in a distributed systems. But I thought I'd actually challenge one of the questions that came up earlier, which is a question that often gets asked, which is how do we make sure that systems are secure by design and that you can prove that by construction? And it's a great debate question anytime you get any group of security professionals together and you challenge them with a question like, how do we harden the internet? People say, well, we need to be secure by design. We have to stop introducing bugs. And that's a really hard question because by whose design? And conveniently, I have a great illustration from yesterday. A new bug was discovered in the SSL protocol. The protocol itself contains a vulnerability that is created by its interaction with HTTP. So the person I'm going to blame is Tim Berners-Lee because it's his fault. It's his fault because the HTTP protocol by design has no security at all. So at some point, we had to come along and tack in SSL and wedge it in between TCP and HTTP. Now, for those of you familiar with the 7-layer DoD model, we're wedging in a layer of abstraction between layer 4 and layer 5. So SSL sort of has to sit in between both of those. And it turns out there's a vulnerability for doing renegotiation that an attacker can sit in between you and a secure website. And when you make your initial request, they can insert a request in front of yours, and it will use your credentials. This is a fundamental break in the way that SSL works. Right? There is no easy fix for this one because it's not an implementation failure. It's an actual failure of the protocol, and it's a failure because we separated security from usability. HTTP works very nicely. It's horribly insecure. We tried to tack on something else underneath it, and really they don't talk together very well, and there's a lot of very easy and obvious control points that as soon as everybody looked at this problem, we were like, oh, look, you can fix it this way, or this way, or this way, or this way. But at the end of the day, we didn't design a protocol well, right? We asked security professionals to secure systems, to secure applications, to secure configurations, to secure operations. Yet protocols are broken. And why is it that we have these problems and we don't see them anywhere else? And the answer is because we're not really looking anywhere else. Right? We're all sitting in a lecture hall right here that is fundamentally insecure by design, and none of us really care. Right? Nobody actually is sitting here saying, wow, I feel unsafe, because anybody could walk into this room. Somebody could conduct a denial of service attack by running in with 1,000 people screaming. That does tend to happen at some campuses. I'm hoping that won't happen to us today. But at the end of the day, complex networked systems present a very easy attack surface. Right? We remember the early days of white-collar crime. You steal half a penny from a bank account. Right? There's no controls against it, and so people would steal half a penny from every bank account. And you skim the interest off of bank accounts. You'd make a good living off it. And it was possible because it became easier to do the attack. Right? Security is always about trade-off. There is no such thing as secure. And it's a hard problem, and we can't just keep pointing fingers sort of further back in the chain. You have the product manager point fingers at the engineer, who points fingers at the architect, who tries to look around and figure out who else to point a finger at. Because at the end of the day, security is about, as Phil just talked about, it's about risk management. And you have to pick where is your risk. And you can't say I'm willing to accept no risk. Businesses are in the business of accepting risk. If you can find me a business that is absolutely risk-free, odds are nobody's making money there. That's just not the way it works. So a lot of security comes down to identifying what is reasonable risk and not shooting for that pie in the sky. We often call it the sledgehammer argument. An old anecdote, how do you secure the data on a computer system, right? You take the computer system, you're going to encrypt the data on the hard drive, you're going to put it inside a locked room with no connections. Before you leave the room, you're going to deadbolt the door 5 times, and the last thing you're going to do is you're going to take a sledgehammer to that machine to completely destroy the data. It's really secure now. It's pretty much unusable too. Probably there was some value there. So a lot of security comes down to picking the right trade-offs and deciding how much risk you're willing to take. At Akamai, we're very fortunate in that our trade-offs are always all around operationalization. And there's a common misperception in security that systems can either be easy to use or they can be secure. I'm actually going to tell you that's bunk. Systems that are easy to use and secure are possible. In fact, if you design them well, they're easier to use the more secure they are, because you thought about things like, how could my user do something stupid without intending to? I'll point back to a really, one of our egg on our face moments. We have a portal application that gives you two choices, and there's a text box. If you pick one choice, you're saying, well, I want to do this action that's very dangerous to a very limited set of things, and I'm going to put in the text box the things I want you to do it to. And below that, there's a button for, no, I want to do it to everything. And these are right next to each other, and we once had a customer go in and put in the list of things they wanted to do this adverse thing to, and then check the box for, no, do it to everything. And they clicked submit. Right? That's an insecure application, and it's a really bad user interface, too. Right? Had that system been more secure, it would have said, wait a second, you gave me a limited set of data, and you told me to do something unlimited. Right? That doesn't match up with what you expected. I'm going to do something bad. Do you really want me to do something bad here? So we've found over time that building secure systems is about making them work at scale, is about requiring them not to need human interaction. Right? Systems that you go, and I'm willing to bet that at least 50% of this room has some pet project they're doing on a server under their desk or in their dorm room or somewhere that's completely unoperationalized. Right? And it's a fun project. At the end of the day, you can't operate that as a business. Whatever you've got there, you need 24/7 support for it. You need to have the ability for redundant failures, to deal with a power outage here. All of those things that you need for operationalization, you need for security. And too often, we're sort of trapped by our market dynamics of get something to market really fast, and the shortcuts that people take aren't always necessary. Some of them are actually actively harmful. People believe that, well, I don't need to do that stuff because I needed to get my market testing first. And there's a very good point there of don't overinvest in something that isn't going to have a market. But there's a lot of the things that people do that are sort of conscious. I refuse to do risk mitigation because I have been told from day one that risk mitigation just costs me money and makes my product harder to use. And that's sort of a big thing we've learned is try to do secure by construction as much as possible, but tie that into real business value. Make the system work in an operational fashion. Get data to the operator. Security is not in the business of running a business. There are a few security companies out there, but usually security is about protecting the business. And the best way you can protect the business is to make sure people aren't trying to bypass your security. So it sort of brings me back to sort of what I consider often the normal cycle of how something gets developed. Right? You start with a cool idea, and you take that cool idea and you build an implementation in the lab. Right? You do a proof of concept because everybody wants a demo. Sometimes the demo is just images, but usually it's a system that might work. Then somebody comes along and you have an argument between the purist and the realist, right? And the purist says, well, you should implement this in this specific language, and it should use the latest and greatest programming techniques. And the realist says, it should actually work. And they have an argument for a while, and you usually end up with a test implementation, and the realist often wins. Where the purist wins, you often don't hear those anecdotes because their competitors got something out to market before them. But then that test implementation you're making money on. Right? You take that out and somebody's going to buy it, and that's a good thing. But now you're sort of stuck with what we call second system syndrome in the development community, which is all of the things you didn't do in the first system that you really would have liked to do, you put into the second system. And you say, this is going to be the single most perfect thing ever. And that's usually where your security professional comes along and says, oh, not only is it going to be perfect operationally, but you're going to have a perfect reference implementation of every control and risk mitigation strategy you could possibly have. And that's usually a recipe for disaster. You usually want to say, let's build the system from the ground up to scale, figure out how much it has to scale. Doesn't have to scale forever, but it has to have the security underpinnings built in from day one, but also has to have the ability to adapt in the future for that day when somebody discovers the protocol vulnerability you introduced 10, 15 years ago that only now is being discovered. And it's sort of a life cycle of a system development. And if you try to sort of jump that to a second system at the beginning, you often don't succeed. And if you put too much on it at the end, you're not going to succeed. The importance for security in systems design is that it is built in the end, it is reasonable risk decisions, and that you understand your trade-offs, that you understand the risks that you are accepting as a business. Right? And if you don't understand the risks, you're not doing yourself any service. And if you think you've mitigated them all, you're wrong. So I think I'll stop there and we'll take some questions.
Okay. Well,